Grade 6, Gay-Lussac's law. This one, of course, we talked about pressure, volume, temperature. This one talks about pressure and temperature. Okay. This is where the volume is usually consistent or constant. So the volume is usually like a steel container, for example. If the temperature goes up, the pressure is going to go up. If the temperature goes down, the pressure goes down. This is best illustrated by this. Okay. I'm just going to put 4 in here, and again, 4 in here. The volume is the same in this case. Volume constant. And as you can imagine, okay, if the temperature is low, these molecules are moving slowly. And if they're moving slowly, like this, okay, there's probably not going to be very many collisions. Okay, yeah.
Is this like why the grease cans can't be heated though?
Yes, kind of, but yes. Okay. We'll talk about that in a second. So temperature goes down, the pressure is low. Okay. If we increase the temperature and make these molecules move very fast, okay, then of course there's going to be lots of collisions. And the more and more collisions you have, the higher the pressure is going to get. This would be an example of steel containers, for example, propane tanks, okay, aerosol containers, et cetera, et cetera. Now, the pressure will increase. It's not quite the same as what we talked about before with equilibrium. So yes, this is how things blow up, but it's not based on the outside pressure has to equal the inside pressure, because that's not really what's happening. Because this is a sealed container now, okay, the outside pressure really can't affect the inside pressure. It could if it was a soft-sided container, but then that's then we get into pressure and volume again. Okay, so that's not this. This basically increases pressure until the structural integrity can't hold anymore, whatever that happens to be. Obviously, if you're using a if this was a steel container, it's probably going to be able to withstand quite a bit of pressure. If it's a piece of aluminum, like aluminum can or something like that, probably not that much, right? So it just kind of depends on the container itself as to how much pressure it can hold. But yes, the pressure increases until basically, well, one of two things happens. It either increases or it increases till it blows up, or it decreases in some cases if you cool it down. Okay, yeah.
So when you throw like a tiny propane can into a fire, is it the propane that's blowing up, or is it the...
Well, yes, because it's combustible. Yes, but to get to that, you have to, of course, it has to break through. You have to heat those up fast enough. Again, depends if the fire is hot enough to get it to its combustion point, right? Then that's a combustion reaction or explosion. If it's just pressure that builds up, like if you had an inert gas, it would still blow the sides out eventually. It just might take, I don't know, it might take more. It depends on how much that can hold, yes? Like, it's hard to say. This looks like this, pressure and temperature, and it's a direct proportion again here, okay? Calculations that involve this, I don't know if you have this or not, but it's P1 over T1 equals P2 over T2. Okay? And again, you'll notice temperature is on the bottom. In this formula, temperature has to be in Kelvin. Volume has to be the same, and it has to be a closed system. Okay? And that is Gay-Lussac's law. Good? Okay? And that's all we're going to talk about there. All right?